So today's lesson is going to be on decomposition. Decomposition is the opposite of synthesis, and decomposition is the second type of reaction on your reference tables. In a synthesis reaction in our previous unit or lesson, you saw that two elements made a binary compound. A metal oxide plus water made a base, and a nonmetal oxide plus water made an acid. So here we're going the opposite way, and we are taking the binary compound and breaking it apart into its two individual elements, for example. We also have a few other different types of decomposition reactions. We can take a metal with a carbonate. It'll break up into a metal oxide and carbon dioxide. We can take a metal with a hydrogen carbonate. It'll break up into a metal with an oxygen, water, and carbon dioxide. So this metal oxide, water, carbon dioxide. We can also take a metal chlorate, and it'll break up into a metal chloride and oxygen. So a decomposition is pretty easy to determine because if you'll notice, we only have one reactant in each example. So if there's only one reactant, then it is a decomposition reaction. So this is one of the easiest ones, in my personal opinion, to determine what type of reaction it is. So let's look at a couple of practice problems. Magnesium oxide. So here is a binary compound. So this is a type A. So I'm going to break apart into my individual elements. All right, magnesium and oxygen. Magnesium is a metal by itself, so it's going to be a solid. Oxygen by itself is always diatomic, and it is a gas. And then we balance. There we go. Calcium carbonate. All right, calcium carbonate. This is a type B reaction. I have a metal, calcium in this case, with a carbonate. So I'm going to get a metal oxide plus carbon dioxide. So my metal here is calcium, and it's going to combine with oxygen. So when I swap and drop, I get calcium oxide plus, according to my reference tables, carbon dioxide, which I know is a gas. It is a binary molecular compound, which are going to be gases unless otherwise denoted. Sodium hydroxide. Oh, I'm sorry. I don't know why I just read that as hydroxide. Sodium hydrogen carbonate. All right, so sodium hydrogen carbonate. This is going to be a type C. I'm going to break down into a metal carbonate, water, and a gas. So my metal is going to be sodium. So I'm going to have sodium carbonate plus liquid water and carbon dioxide. That just told me it was a solid according to my reference table. Okay, so there we go. And then we just have to make sure we balance it. If I put a 2 in front, that should balance it out. I have 2, I have 2, I have 3, 4, 5, 6, 6. Yep, so there we go. We now balanced. All right, potassium hydroxide. So potassium hydroxide is going to be a metal hydroxide. It's going to break down into a metal oxide plus water. So my metal is potassium, and when I swap and drop with my oxygen, I get K2O plus water. And then I have to balance it out, put a 2 in front. So this we said was a type D. lithium chlorate. Here I have a metal chlorate. All right, so this is a type E. I'm going to get a metal chloride plus oxygen gas. So my metal is lithium, and when I swap and drop that with chlorine, I get my metal chloride, lithium chloride. Plus, it says a oxygen gas, which we know. Here's a gas. And then we're going to solve, or not solve, I'm sorry, we're going to balance it. So type E. So to balance this, I'm just going to put a 2, 2, 3. There we go. And finally, sulfuric acid. So here's sulfuric acid. Now this is going to be type F. This is a acid, makes a nonmetal oxide plus water. So this is going to basically work out the opposite of a synthesis. In a synthesis reaction, we took this oxygen to make SO4 sulfate. So now we're going to basically remove an oxygen. So if I remove an oxygen, that gives me SO3 plus water. Okay, so there we go. And that's how we're going to solve these problems for a decomposition. My suggestion to you, do not become dependent on this reference table. You are provided it for this portion of the course, but when we become all AP all day long, you will no longer be provided this reference table, and you will be expected to be able to solve these problems without the reference table.